Okay. Hi, Sai. Is this? Are you on?
Yes, Raj here. We are actually live now, so I'll just give an intro and we can start in 1 minute.
Sure, whenever you're ready.
Yeah. So I think the audio is clear, right, Nalini? You're able to hear me well and good, right?
Yes. Can you hear me okay?
Yes, it's okay. It sounds pretty good.
Okay, thanks.
Hi everyone, welcome to Manage Engine Knowledge Webinar Series once again. I'm Raj, Product Manager from Manage Engine, and I have Mrs. Nalini Elkins, Insight Products, to host the webinar. So welcome everyone. The new attendees have been joining for the IPv6 Transition Techniques webinar, and welcome back the attendees that you have attended the old webinar, the one on IPv6 address planning thing. So this is just a continuation on that part, and this goes into the transition techniques and a couple of tunneling modes and that Nalini is going to talk about. And I hope everyone knows Nalini. Nalini is a renowned IPv6 expert in the industry, and she is a regular speaker at conferences such as SharkFest, NAPPT, and Google Fest and things like that. And people who are interested to look at the previous webinar, you can go to www.netflowanalyzer.com and you can have a look at the first webinar that happened last month on the IPv6 address planning. And the current webinar that's going to talk about on the transition techniques, that's going to Nalini is going to deep dive into the transition technologies and transition methodologies or tunneling methodologies that's currently people are evaluating or people are deploying for IPv6 networks. So this is the new thing. And at the end of the webinar, we obviously have a Q&A session where you can throw your current IPv6 deployment doubts or anything related to IPv6. Also, Nalini is a CEO of the Insight Products. So Insight Products is a network troubleshooting and network consulting company. They have a lot of products in terms of packet capturing analysis and a lot of expertise they hold. So you can also ask questions in terms of that. So yes, the introduction is pretty much I'm done. So I'm going to transfer this presentation to Mrs. Nalini Elkins. Welcome back, Nalini. The call is yours.
Okay, thank you so much. Whenever you're ready, if you'll give me control, I'll go ahead and start up the presentation.
We have released the control. You can share your screen. We're on. You're live.
Okay. Yes. Okay. I hope everybody can hear me. Okay. Thank you so much for attending this presentation. Today we'll be speaking on IPv6 transition. Now, let's take a moment and think about why is it that we're talking about transition techniques? Well, the problem is that IPv4 and IPv6 are incompatible protocols. And so if you're using IPv4, you have to integrate IPv6 somehow into your network, but it has to be in such a way that it doesn't conflict with IPv4. As I say, those two protocols can't talk to each other. So today, the state of events is that most people are IPv4 only. And at some point, we will be IPv6 only. Recall, these are incompatible protocols. So what do we think? When do we think those dates will be? When do we think we will be IPv6 only? Well, you know, this is only a best guess. Possibly 2022. Some people think sooner. Some people think that IPv4 will be around for many, many more years to come. And that's probably very likely. You know, nobody knows. Nobody knows what's going to happen in the next 5-10 years. But what we do know is that for many, many people, the transition, not really the transition, the integration of IPv6 into their networks has begun. And in this presentation, what I'm going to talk to you about is some of the motivations for the integration of IPv6 into people's networks. I do not see most people getting rid of IPv4. Having said that, there are some people who are talking about that. And I will tell you that in a moment when we get to the relevant slides. So this presentation is on transition technologies. Because these two protocols excuse me, are incompatible, what we have to do is we have to figure out some ways to either convert V4 into V6 and vice versa, or coexist. And so I'm going to talk to you about 3 different technologies for either conversion or coexistence. So let's continue. What has been the motivation for going to IPv6? Why are we talking about this now? Well, one of the biggest motivations is that IANA is the organization, the Internet organization, that allocates IPv4 and IPv6 addresses to everyone. What the structure is that IANA allocates groups of addresses to various regional Internet registries, or RIRs. These Internet registries are such as APNIC for the Asia-Pacific region, RIPE for Europe and the Middle East, ARIN for North America, LACNIC for Latin America and South America, and AFRINIC for Africa. I believe APNIC also has Australia. So in any case, one of the big motivations is that IANA ran out of IPv4 address blocks, large address blocks. They ran out of them in 2011. So if IANA cannot allocate blocks to the regional Internet registries, then soon they will run out of what they currently have. And then they will have to allocate IPv6 only. You can go to this website and see what is the current state. and the projected exhaustion date, projected, mind you, for all the regional registries. If you look at APNIC only, you'll notice that APNIC themselves, they are on their final IPv4 /8. And you can go to this website at APNIC and see what phase they're in and what they're going to. And you can see that RIPE for Europe and the Middle East and ARIN for North America are projected to run out soon. And as I say, these are still projections for when they will run out. And so, if they run out, well, then what? Well, what will happen then is that if ARIN or one of the Internet registries can only allocate IPv6 addresses, then down the road here, let's say that takes maybe until next year for ARIN or RIPE, then since they are the people allocating addresses to ISPs, ISPs are providers such as AT&T, Comcast, your Internet provider. So the Internet providers, they have some IPv4 address blocks left, and so they will be preserving them. But having said that, if the Internet registries run out, then soon enough, and by soon enough, I say the next 5 years, some ISP is going to run out of the V4 address blocks. Now, it will most likely not be the very large ISPs, but it may be a smaller Internet registry. If we're talking about the United States, then it may be somebody in one of our mountainous regions or maybe one of the islands, such as Hawaii. And if folks from Hawaii are on the webcast, I love your islands. but in any case, some small ISP, and then starting to become the larger ISPs, they'll run out of V4 addresses. So that's when the chain of dominoes, that's when the links start falling. Okay, so then the customers only will get IPv6 addresses. If you've got an IPv6 address, you're not going to get to an IPv4 only website unless you do something else, and that's what we're talking about. What is that something else? For example, if you have a bank or if you have a university, whatever, if you have an IPv4 only website, that IPv6 address will not be able to get to that website unless you do something. So, you know what people say sometimes. They say, well, this is an ISP problem. Why don't I'm going to let them take care of it? Yes, ISPs are offering tunneling and some other kinds of transition techniques. Having said that, what a lot of people are asking the question is, what is the performance of these techniques? What is the user experience when you use tunneling? What are the security risks? And the other question, which is, of course, that comes in when you're running networks, is how much is this going to cost me? And today, they may say, well, you know, today, this is not going to cost you any more, but in the future, who knows whether the prices can go up or not. And why shouldn't they? They're offering you a service that maybe not many people need. Many people have asked, what is the killer app for the transition to IPv6? What is the business need? Well, the killer app is access to the internet and access to your websites by everyone. Today, the internet is used by, I will say, 99.99% of every business that exists all over the world. In fact, if you look at the penetration rates by geographic region, you'll see, of course, that North America is leading. Most people in North America use the internet, followed very quickly by Australia and Europe. And what we want to do in the internet community, of course, is to have the rest of the world using the internet at the same levels of North America and Australia, etc. And how will they do that? They're going to have to do it via IPv6. So if you're a global company, if you're international, this is something you need to think of. And if you're a United States or European company and you have a global presence, you need to consider that many people in the future will be accessing your website by IP version 6. So, again, we're talking about transition techniques. This is the basis for why we're talking about this. The United States government, in the light of everything that I've been talking about, has put out some federal mandates. And these federal mandates are for fiscal year 2012 and fiscal year 2014. And this is right out of the Office of Management and Budget Directive. This is the directive for IP version 6. And you'll notice what they say. The thing that has to be done by end of 2012 for federal agencies is to upgrade their public or external facing servers and services. What we're talking about is the services that face the internet. That's what they mean by public or external facing. When you hear that, when you hear external facing, you're talking about, people are talking about facing the internet. Internal facing are those on your internal network that do not necessarily go out to the internet. So what is it that faces the internet? Well, so your web portal, your website, email, DNS. If you are internally running any ISP services, and I certainly know companies who do that either for affiliates, business partners, whatever. And the mandate is for them to use native IPv6 by the end of fiscal year 2012. This is very interesting. What I'm going to be talking to you about is transition techniques. You'll notice they did not say use translation, use tunneling for IPv6. So this is very, very interesting. I will show you some of the methods for coexistence as well as translation. One of the things that happens is when the U.S. government has a mandate, why then many other countries follow, and of course many of the corporations within the United States and Europe pay attention to such mandates. Absolutely, many other countries around the world have plans and mandates themselves and for IPv6. I'm talking only about the United States of America. So then, let's say that we get 2012 done. What then are we supposed to do? If by 2014, client applications that communicate with the public internet servers should use a native IPv6 by 2014. So how are we going to get to this kind of level? This is where the transition and coexistence techniques that I'm going to be talking about come into play. I'm trying to set the stage here so that you can understand why the mandates have been put out and why the transition techniques are necessary. We will be using transition techniques for quite a few years, probably the next 10 years at least to come. One of the other problems that comes up is that large business organizations take a long time to integrate new processes into how they do business. But if you think of it as a large ship, it takes a long time to turn the ship around. This IPv6 integration is most likely one of the largest projects that we will be working on in the network area for at least the next 10 years. Some of the companies that I'm working with have a 10 to 15-year project for doing this. It depends on how large you are. Some companies think this is a 3 to 5 year project. Others, as I say, are in the 10 to 15-year project. And why? Because every group that in any way touches the network has to be involved. The security, applications, hardware, everyone has to be involved. And many of the large companies I work with have things like lights out data centers. They have data centers which operate with very few people, maybe a skeleton staff, and they have much automated operations. In order to do something like that, if you're going to respond to messages, sometimes these messages have IP addresses embedded in them. And so you had better be able to respond to an IPv6 address as well as an IPv4 address. And in this whole arena, working as a team is really, really imperative. And there are, as I say, a number of companies that I know now that are in the stage of forming such teams and figuring out what's the roadmap, what is that team going to do, and so on. And one of the things that team has to do is figure out how we're going to communicate. How is it? Where do these transition techniques work? What is the method and policy for coexistence? What transition techniques will be used? As I said, this is a very long, very long-term project, but this is what many people are working on now. That really the first thing that has to happen, as I say, the most important thing is to convert your external-facing equipment because of the reasons that I talked to you about earlier. Because there will be, most likely in the next 5 years, someone who has only a V6 address that's going to try to communicate with you. And how are they going to do that? That's what we're going to start talking about. There may also be government interfaces. Those may need to be IP version 6. How do we do all this? And now we finally start talking about what is the methodology for coexistence. We're going to discuss 3 different methodologies. Dual stack mode. Dual stack mode is a coexistence methodology where tunneling and translation are they're transitional. I mean, they convert the conversion technologies from one to the other. And for each, we're going to discuss what the benefits, drawbacks, and security issues are. The most straightforward and I suppose best practices. This is what we'd like to get to until we're at native IPv6. What we'd like to have is dual stack, and dual stack can be done either for a router or for a host. And what that means is that the interface has both a v4 address and a v6 address. Now, this can be different interfaces, let's say on the router, or the same interface, if you have different interfaces, then that router is running in dual stack mode. If you have it on the same interface, then that interface is running in dual stack mode. In any case, by and large, for most of the routing technologies, you need a v4 route and a v6 route. This is not a lecture on routing technologies, so we can discuss. There are some ways to integrate that, but by and large, other than one exception, this is what you're going to have. You're going to have different sockets for v4, different applications for v4, or it could be a dual stack application. In any case, SIMs are separated, and they can receive both v4 and v6 packets. So, if you can, this is a very good thing to do. This would be considered best practices. But what are the implications of all this? It's easy to say we're going to run dual stack, that we're going to run a dual stack mode v6 website. In reality, though, it's the applications. The network portion is in some ways easier to do than if the application has to be rewritten. Within the application, you're going to have a completely different socket descriptor for v4 versus v6. If you have something like a middleware, MQ series, WebSphere, Apache, if you have some kind of middleware, then that middleware may be capable of doing that conversion itself, and it may be shielding the application from any knowledge of the IP address. In that case, your job is much simpler. Then you only have to deal with that particular middleware to make sure everything around it, including documentation for all clients, is all done properly. If you've got something that's using raw sockets or going directly, that's a different question. It may take much longer time. Then you have to decide what's preferred. Is v4 preferred versus v6? What's the performance going to be? And what's the impact of everything we're doing? Security issues start coming into this as well. You may not have the same policies. You could be subject to different kinds of attacks. In fact, this is one of the biggest problems in this whole area. And so I would really recommend, whenever you start working on such projects, that security be involved from day one. So that is dual stack. That is a coexistence method. If you're not going to do coexistence, then you have to do some kind of conversion. And one of the problems is there are many, many methods for doing conversion, either tunneling or translation. And so that's why I say one of the first things to do is that you have to decide what's our policy going to be for doing translation or tunneling, Where are we going to do it? Are we going to use, and what methods are we going to use? So I'll talk to you about how it works, and then a bit about some of the technologies themselves. Each one is different, but the overview of how translation works is that generally you have some kind of function. It may be implemented in a router. It may be implemented in a load balancer. There are a number of server load balancing products out now which do translation. Of course, the routers often have that as well. And what they'll do is translate the V4 packet to V6 and vice versa. And so then let's say it translates to V4. It will travel across the network as a V4 packet and then come back on the other end and be translated back to V6 again. So let's talk about tunneling. Tunneling can work in the same way, but tunneling embeds the packet. You have your V6 packet and you embed it somehow in a V4 packet. Oftentimes the tunneling is in the router, but it can also be in a host. You can do tunneling inside a host as well. So let's look at something. This is actually even an old display. What I did was I implemented IPv6 on Windows. And you'll see that without me defining any kind of tunneling methods, I'm going to tell you I didn't. All I did was I said IPv6 space install. And lo and behold, I have all kinds of IPv6 type addresses. But also, they've given me a Teredo tunneling interface, automatic tunneling pseudo interface. In fact, two of them without me doing anything. So that's why I say many of these tunneling techniques are implemented directly in the operating system, and actually they can be security threats as well. And so it has to be paid attention to what tunneling techniques exist, whether they're enabled, and what can be done with them. And what's the extent of the threat? Is it only the LAN? And in many cases, that is what it is. So let's talk a bit about tunneling. Let's take the case where we have IPv6 hosts and a V4 network. What we're going to do is embed this V6 packet inside a V4. You may actually have an IP header and then the V6 packet, or you may have an upper layer protocol. And generally, it's UDP. In fact, I've never seen a tunneling methodology that uses TCP. You can see that that might be very, very expensive to do. And of course, at the other end, the packet is decapsulated. Why are we doing this? Well, we're doing this so that we don't have to convert the network. But at this point, you'll see we do have hosts that are either native V6 or that have dual stack capabilities. So your question when you're using tunneling is what's my problem? Do I have a network that can't be converted and I have some applications that are V6, or do I want to talk to someone else that's V6? Why am I using tunneling? You can see that somehow, for example, if there's a government mandate to use something that's a V6 application, let's say that I'm just making this up completely. Let's say that the U.S. Treasury says that you can only do something via IPv6. Why then, if you want to interface with the Treasury, you may use tunneling. Or if you have a V6 application, those are becoming they're starting to come out. They're not common yet, but I suspect in the next few years we will see more and more V6 only applications. So then you decide, what tunneling method am I going to use? There are, let's say, a number of them, and some of them are in the routers only. Some of them have security. Some of them are done at the level of the ISP. You know, we don't have time in this small session to discuss everything. So as I say, I'm going to tell you about these, and then you can investigate yourself as well. Or of course, we have more classes on this. So let's talk about a couple of methods. There's one quite common one called 6 to 4. And this has only an IP header, only a V4 header, and then the V6 packet starts. The protocol you'll see in there is a decimal 41, which is IPv6 embedded inside of IP. I have a packet that I will show you in a moment, which has a tunneled packet. Then Teredo, which we saw on that Windows IP config display. Teredo embeds IPv6 inside a V4 UDP packet. The short version of why we use something like Teredo or Tunnel Broker is that it can then go across a NAT. You may not be able to do 6 to 4 across a NAT, but you can do UDP across a NAT. So let's take a look at an actual packet that's doing some tunneling. This is a packet from the free Wireshark product, an excellent product, which we all like very much. And of course, the price is right. You'll see here, the first thing we see is the IP header. It is a version 4 header. And you'll see within there, the protocol is IPv6, hex 29, or decimal 41. And you'll see then, instead of the actual protocol packet, which you might expect to see, we then see the embedded IPv6 packet. You'll see here IP version 6, traffic class, flow label, etc. And then, of course, the big giveaway is the source and destination addresses, which are in V6. And then starts the actual protocol header, if you will, the upper layer protocol, which is TCP. In this case, it happens to be an FTP packet. Notice here then the next header. This is what replaces the protocol field in IPv6. It's more complicated than that, but for starters, if you think of it that way, that will be good. So notice that we have your IPv4 header, then an IPv6 header, and then starts the upper layer protocol. So that is that's what we have here for tunneling. There are a number of security issues for tunneling. If you have someone who can somehow get into one of the intermediate routers, then that can pose a threat. Every router can be an attack point. And so for tunneling, and actually for translation also, the shorter the tunnel, the better that you have. Now, what can be done? Well, one of the things that can be done is that a packet can be sent directly to what is called the decapsulator. If you can figure out what is the packet, what is the router which is doing the other end, you can craft a packet and send it directly to that decapsulator. So if you're going to use this kind of methodology, you should make sure that your decapsulator is making certain checks. For example, that if you get a packet, it's actually from the encapsulator and not from somewhere else. And you're getting it from the interface that you expect and not some other interface. And if you've gotten a number of different packets that you've had to with wrong addresses, then you should discard them, and this should be seen as a problem and a threat. Now, the thing you might think is, well, so what? So what if we can craft a packet? Or so what if we can get a packet through? Well, here's a packet that I crafted with multiple routing and fragmentation headers. And I can easily send this to the decapsulator. And this packet contains within it a deprecated a header, something called the type 0 routing header. Now, just because a header is deprecated doesn't mean I can't craft it. And it doesn't mean that all routers or all hosts, if I happen to send it to that, have actually deprecated it. Or you don't know what they will do. To cut a long story short on the routing header 0, essentially I can create a denial of service attack with something like a routing header 0. So that's something you want to be quite careful with. There are, of course, quite a few others. In general, there are some threats for tunneling. The firewall may not know how to all the different tunneling techniques, so then the V6 packet gets through. Once it gets through, do you know that that V6 address is following your standards or rules? Whose V6 packet has gotten through? And then, of course, as I say, you can have a malicious packet like a routing header. You can pretend that V6 packet can also go to a node which is working with it. I mean, there are many different kind of threats which can happen. So I'm going to tell you some best practices for tunneling. If you're going to do tunneling, I would recommend that you use something with an authentication scheme. I have to say that if you're going to do it, my recommendation is that you consider GRE, Generic Route Encapsulation, with IPv6 for protection. And whenever you're dropping packets, you should not send a notification that the packet has been dropped. The only thing that does is to tell the malicious sender that he's gotten something. And it can also be used to create a denial of service attack. Okay, so let's talk now about translation. It sounds easy to say, well, I'm going to take a V6 packet and I'm going to change it to V4. Well, easier said than done. What you need to do is convert a V4 header to V6. You need to find what address it is and then do some routing. There are a number of methods that are being used for that. Some are deprecated. For example, NapPT is considered deprecated because of security issues. The two of the things that I see many people looking at, investigating that right now, are NAT64 and SLBPT. SLBPT is server load balancing protocol translation. And that is implemented in a number of load balancers. I'm not going to talk about any product specifically, and actually we haven't time now to talk about the techniques. Let me just tell you, though, about what the RFCs are. Take a look at RFC 6145. Basically, that controls taking a v4 packet and rewriting it to v6. And for IP, TCP, UDP headers, this is somewhat simple. There are issues, of course. If you're using things like flow label, that becomes an issue. But the biggest challenge is ICMP messages, because there are quite a few ICMP v6 messages which have no counterpart in IPv4. And so we have to decide what we're going to do with that. Another big problem is, how do we do things such as path MTU discovery? One of the big differences between v4 and v6 is that in v6, path MTU discovery is required, but in v4 it is not. The reason why it's required is that in v6, the routers are not allowed to fragment packets. Only the source can fragment packets. And so you have to do path MTU discovery. So as I say, this is one of the problems that's posed by translation. Some of the other issues that come up is there's no v4 options. Not all the extension headers are supported for v6. And one of the biggest things is best effort. It's only done on best effort because there are a lot of differences. For mobility, IPv6 mobility, for example. So what happens if you can't translate a packet? Well, it's thrown away. Multicast is not supported. There is no the v4 multicast is not equivalent to the v6 multicast. If we discuss security issues, there are a number of them. Let's go through them. One of the biggest issues for translation is that it poses a single point of failure. Most of these translators, in fact, everyone that I have seen, are what's called stateful. That means that the packet has to come in and out of the same device. That poses a single point of failure on your network. If that packet, if that connection has to go through that device, whether it's a router or a load balancer or what, that is a single point of failure. It is a good question whether you want to put such a device in front of your website. As I say, it's certainly worth discussing. Transition technologies are intended as just that, transition. That means you use them for a short time, and then you get to either native IPv6 or dual stack mode. Another problem, of course, is man in the middle. Let's say if somehow you can give the v6 node a fake prefix, or you know what the prefix is for that translation router, you can play a man in the middle and get all the traffic that's coming to and from. There are problems with IPsec when you use translation. AH, as I say, we haven't time to discuss all this in detail, but AH can't be used at all, and ESP has problems. DNSSEC has a number of issues with translation. Now, DNSSEC is not something that most people use, so that may not be such a problem. But these denial of service attacks, those I feel to be more serious. The statefulness and the denial of service attacks. One of the things, if you're using dynamic address allocation, allocating from a pool, you can just get, an attacker can use up your pool. And in any case, you can do a resource depletion. If you figure out the translation router you can attack it and cause a denial of service attack. And of course, you may be able to bypass firewall filters with such translation devices. You know, it seems like all the transition technologies have their flaws, and there's no question. There's no question of that. All the transition technologies indeed do have their flaws, and in fact, that's what they're intended to be, is only transition technologies. And so let me say, I know that we have a number of questions on this. If you want the presentation, you can download it at the next foil. But what I will do now is I'll take a few minutes and tell you about Inside Products, my company, and some of the things that we can help you with in IP version 6 and IP version 4. These foils are available at the link that I showed you, and I will be showing that link throughout. My company offers a number of different products and classes for IP version 6 and IP version 4, of course, and SSL and security. The product I'm going to talk to you about today is IPv6 Problem Finder, which will basically turn a trace into English. And why? Why do we need this? Well, you know what? You don't need to take a trace much of the time. I love taking traces. A trace really helps me to understand the protocol. But you know what? What happens on most networks is that 20% of the problems take most of your time. I can't tell you how many meetings I've sat in, I've participated in, just try to solve problems. And for most of those problems, a trace is the thing that will be the most helpful for you. I hope you can see the guest book entry at the end. You can download these foils from there. But one of the things that has to be decided is, when are we going to trace? And what is it that we're going to trace? For many of the problems, you don't need to do that. Just take a look at what the last thing you did. And oftentimes, that'll be the problem. But if you have things like performance problems, low throughput, VPNs that are dropping, or, of course, SSL issues, or, oh my gosh, IPv6 problems, you know what? Then you really need to understand the protocols. You really need to start taking traces to understand. I am showing you here an SSL handshake. There are many different packets that are sent for the handshakes, and oftentimes the certificates need to be decrypted. We need to find out exactly what's going on. If we're doing IPv6, then one of the first things that happens is that we need to see what the throughput is. And a very good way is to go ahead and take a trace, figure out what the throughput is and where things may be slowing down. This is really an essential tool for your V6 lab. Let's think a little bit about how do we go about this process of turning packet traces into English. Well, let's say we've got hundreds of thousands of packets. First thing we do is we say, well, what's the packet range? What devices do they have problems? Then our problem finder packets will guide you through the analysis. You know, if you're solving network issues, if you're looking at network issues, there's often clumps. Either there's a number of devices, whether it's a subnet, whether it's a route, or there's a time frame where there's congestion. And so So let's take a look. This is a screen from our TCP Problem Finder product, and I have fed in 500,000 traces, and then he's telling me, look, if I were you, I would concentrate on packets 500 through 749 and 750 through 999, and these are the connections that I would concentrate on. And we've looked at a number of different parameters. This is the overview part. Say, okay, if I were you, I would drill down and take a look at these. And then what we can do is start doing a detailed analysis. We'll give you recommendations and lots of guidance on exactly what to do. We go through all the different problems that we've found, whether it's resets, the other end not listening. There are many performance errors, many different kinds of errors, connections that are hung, and then what we have to figure out is, well, where did this happen? You've told me what happened, but where was it? So we'll tell you what ports, what source networks, whether it's V6 or V4. We'll break it down. I'm showing you some V4 right now. And then you can go into the session detail and say exactly what happened. And this is a very thorough analysis. Probably each session has a 2 or 3 page analysis from duplicate segments, duplicate acts, out of order, selective acts, data flow, throughput, many things. And of course, window analysis. And you can just imagine how long it would take you to do such an analysis. You know, we can solve problems sometimes in half an hour or an hour that other people have spent days and weeks trying to solve. And I say this because we've done it. You can see how if you go through this analysis, how much time it's going to save you. And especially if you get into something like secure sockets layer. Oh my goodness, we pinpoint exactly what packet in the handshake went wrong, what encryption algorithm you're using, all of it. And this is one of the most difficult things to do is the handshake analysis. And you know, if you even have 1 or 2 handshakes, that's one thing. The other day, I worked with a customer, Trace, and he had over 1,000 SSL handshakes, and trying to figure out what went wrong in that, including the timing parameters. Oh my goodness, that is a huge amount of work. And with SSL Problem Finder, in 5 minutes, we had the answer. 11 out of the 1,000 handshakes were bad. And so I want to take this opportunity to thank you all for attending, and we'd love to have you come to more of our sessions. We offer a free webcast once a month, and I know Manage Engine offers a free webcast itself. We have a cooperation with Manage Engine is a wonderful cooperation for us, and we also have IPv6 information exchange meetings. Both are free. Again, if you want to download this presentation, excuse me, here's the link for the download. And you can also go up to our website and, of course, contact us for our product, consulting, and classes. We are working with a number of organizations right now to lead their efforts in integrating V6 into their network. And we have a number of classes coming up. I believe in October, we've got a number of classes for IPv6. As I say, this is just a flavor of what you need to learn. We have a V6, an 8-hour introduction to V6 class that is web-based. And of course, I tell you, when companies get serious about implementing V6, they ask me to come on site, and I start teaching a number of groups of people, and you can see how much I love packets, and we do a lot of trace analysis because really that is the best way to learn. So let me thank you all for attending, and I know there are a number of questions here, and let me see. I've got a couple of minutes, let me see if I can answer one or two. There's one question. Oh gosh. Okay. Here's one question. It seems like dual stack is the preferred way to go. And having said that, why would an organization not use dual stack? That's a very, very good question. And let's just take the example of a website. You may have applications on your V4 website that are not able to handle a V6 address. And so if you start sending it V6 addresses, it can't, it's not going to work. And so you're going to have to do something to work with that. So I guess that's one of the application not being able to support it. You may not have your firewall rules done. There's a huge number of policy issues that come up also. And let me take another question real quick, and then if you have other questions, do please send them to me, and I'm happy to answer. Another question, is it recommended to have the router be dual stack and separate the interfaces to V4 and V6? Very, very good question. Yes, it depends. Depends on what your routing algorithm is. It depends on if how you're going to structure your routing. That may not be a bad idea, and that way, it's real clear which interfaces are doing V6 and V4 instead of having each router or each interface be dual stack. You have a router with different interfaces. In some ways, there's a little more control, but you have to consider, is there any V4 traffic that's going to need to come into that interface? Because if there is, it's not going to be able to come to it. So anyway, again, let me thank you for your time. Raj, let me turn the session back to you. And thank you again for this opportunity.
Thank you, Nalini. That was an incredible session. Thank you for hosting this IPv6 webinar series. I hope it's going to be very, very helpful to our customer base and other users that joined today and the last session. So as Nalini said, so if you have any questions on IPv6 address things or our IPv6 transition techniques or any other IPv6 related stuff, you can contact Nalini. And any sales inquiries, you can actually go to sales@insidethestack.com for Inside Stack. So they have a list of products that can do a lot of IPv6 expertise. And also, all you guys know, Manage Engine is sponsoring this webinar for IPv6, and it's a knowledge webinar series, and it's going to be a continuous effort from Manage Engine. So there is going to be a lot of new knowledge webinar series are going to be launched every month. So thank you very much, everyone, for joining here today. And for any other information, you can contact support@netflowanalyzer.com for any questions on the IPv6 or network monitoring or bandwidth monitoring aspect. So the basic NetFlow Analyzer product from Manage Engine is a flagship product for bandwidth monitoring and network performance management. So thank you very much for joining here today. Thanks a lot. Thank you, Nalini.
Thank you so much, Raj.